Okay, there we go. No, that was all me. That was all me. Got it in there. Yep. So no, what was going on there is, like I said, I had to set up these new screens in OBS, and I don't have anybody to actually dicker with them. So anyway, let me start over. Guys, thank you for being here. I am pretty excited about doing this. I realize that there's a lot of cool videos on YouTube that are blacksmithing related. They're old stuff, but you don't ever have anybody to actually sit there and go over it. Now, there's plenty of people that review movies, but we're blacksmiths, so we want blacksmithy things. And I think that there's a tremendous amount that you guys will be able to learn just from being able to watch one of these particular videos. And let me point out some things, because most of you out there have never actually seen blacksmiths at work, real blacksmiths, not somebody who's a hobbyist, not somebody who's demonstrating what the work was like in an actual shop. And there's a lot of things that are in there that you guys are going to be able to pick up on. And I was like, man, we've got the internet stream now. Now you've got all these jackasses, out there that are reviewing Minecraft. What about blacksmith videos? And I'm like, wow, I can do that. That's going to be awesome. So now, of course, there's always questions about fair use, and I want to tell you guys, I don't like grabbing anything that don't belong to me. So I actually reached out to the people that had the rights to this video, and I actually spent probably a couple of hours trying to track these folks down. I can't find the owners. The businesses they had seemed to be shut down. So I made a good effort to actually ask permission to review this video, although technically I don't think I need to have the permission because of fair use. But like I said, we always try to mind our manners and at least pay the courtesy of the folks that film these things, because they did, they did a whole lot on that end in capturing this stuff. So this particular video was done by a Peter Vogt, V-O-G-T. I think in German it's actually Vogt. This was, he was actually in the military, I think out of Orlando, Florida, but he was on vacation, and he actually filmed this with a combat cam, like an iCam or something like that. And so a lot of this was done on a military base. Actually, the processing, that's all the history I could find about it. However, it's about the Pioneer Axe Company in Oakland, Maine. This, again, was about 1960 or whatnot, and there's a little bit of backstory in there, but one of the things I want to jump into is actually what I want to kind of go over in this video is the way that these guys are working, and there's going to be a lot. How they stand, how they work, because you guys have never seen this stuff. You guys have never seen actual blacksmiths, for the most part, in a shop environment, which is different than somebody that's demonstrating or somebody's, out in the garage. So I'm going to make sure you guys can hear this stuff. And let's see. Let's get cranking here. Okay. Now, my question is, guys, can you actually hear the audio coming from the video? Nope, no audio. Okay. All right, let me make a quick change here. Let me add this real quick. Audio output capture, add source.
Still, but just barely, produces its line of fine handmade axes. Each axe starts
there we
as a
go.
sheared
That
off
should be
hunk of
getting it. You
barred
guys got it
beam
now?
And will eventually end up a 3-pound axe.
All right.
Wood's been starting it.
Fantastic. Again, I'm having to learn how to get a lot of this stuff going. So, all right. So a couple of things starting out here is, like I said, we're going to look at the fire marks right here. Somebody already tried to burn this place. You know, I always think about, blacksmith shops. I always want them to be like, marble floor, vaulted, clean. And then I see everybody else has shops with broken windows and burnt panels like I do. It doesn't make me feel so bad. All right.
Each axe starts as a sheared off hunk of bar steel and will eventually end up.
Now, what they're using here is this is called an iron worker. And this guy was meant to be run continuously. So if you're watching, these guys aren't pressing a button or anything of this nature. This is actually set on a continuous run. So this thing just sits here and does this number like this all the time. It does not stop. There is no stop button until you cut the whole machine off.
Earl Wood's been starting this process most of his working life, and he's 52. Elwood Manson, at 47, is considered a youngster.
Now, if you saw it right there, they got their timing off. So instead of actually trying to cram it in there, they had to quickly move the piece out of the way because it would have just screwed it up. Because again, it doesn't stop. You had to absolutely be in rhythm with your machines to make this work well.
But he's the master craftsman. Neither has an apprentice.
Now, one thing I want you to pay very close attention to. Watch when his tongs grabs the stock. Well, you missed. Let me go back just a little bit. Back a little bit more. More backer.
As an apprentice.
Look at how the tongs exactly fit the material. So one of the things I'm going to point out at several points in this stream is that I want you to notice how every set of tongs, everything fits the exact stock that they're working on. There are no general purpose tongs. There are tongs that fit each stage of this work. You hear me talk about specializing in tooling, and that, you really can't. If you ask me what I need to do to blacksmithing, that's a bad question. If you ask me what you need to do in S-hook, I can tell you what tool you need at every point. And in this case, the tooling tree is considerable. So we'll keep going.
In an oil-fired furnace, each bar or pattern reaches intense red heat. And the first step in forming the pole or head of the axe is the...
Now, this is something that kind of blew my mind. Now, in the video, the gentleman refers to that this is an oil-fired furnace, and they're making axes, so they're getting enough temperature to forge weld with. Now, again, this is up north, so I'm not familiar with the technology, but if you look here at the piping that is set up for these forges, this looks to be, I don't know, actually I don't know what this is. If I were saying that this was natural gas or propane, I would say that this is the piping for that. But the gentleman specifically said an oil-fired furnace. And the truth is there doesn't seem to be a tremendous amount of flame coming out like the waste oil furnaces that I'm familiar with. So there's a question there. The other thing, and this is where you have to stop the video and really look at the details here. So a couple things. If you'll notice up in here, this is known as a line shaft. A lot of the times these particular mills were run off of water power. In fact, earlier in this video, it's right by a river. So probably now it's run off of a gas engine. But this line shafts and ends up actually running every machine in the shop, including these tilt hammers over here on the side. But there's lots of little details you guys need to pick up on. For example, look right here. Look at this hose. And I can't tell, that was laid over. They've got a hose run up there, and I'm assuming is for hot water. But you've got different pipes and clearly different pieces in there that I have absolutely no idea what this hose would be, why it's in the barrel, and why the barrel also has a steel pipe with a valve there. Unless it was to fill up the water, I have no damn idea. Also, notice the feet of the furnaces over here are actually set in the concrete, except for this one, which literally appears that they've got a piece of 2x4 or something equivalent holding up that side of the forge or whatever it is. Again, I I have to absolutely say how that warms my heart, because it's not only my shop that has weird crap propping stuff up. All right, let's go ahead.
Begun. The ends of the pattern are plated or flattened under the uncompromising steel faces of the trip hammer. The pounding head is strapped by heavy steel bands to a huge beam of solid rock maple, which rises and falls by cam action. On the anvil, the pattern is doubled over to form the eye of the axe.
Now, let me stop it right here. Couple things. All right, so first of all, look at the Hardy that's on the anvil here. It's not flat. Now, they bent this thing over, but my question is, this thing is bent in that fashion for a very particular reason. So I wonder if that actually started the bend. But no, see, they've got it laid across here. So why is it that it's actually got a crook in it? Is that something that was intentional? Or are they using a Hardy and that's just what they had? I don't know. That's a good damn question I don't have an answer to. However, the other thing I want you to look at, again, look at the tongs. Exactly fit and match to this piece. Now, these are clearly a little sprung. Look how he's got the handles crossed over. They probably could be fixed. But again, they fit very snugly on this piece.
The pattern is doubled over to form the eye of the axe. Finally, the two ends are then welded together using granulated borax as the flux. The basic pole is now ready for a blade. Welding a cutting edge of high carbon steel to the softer pole of the axe is the second.
Pay close attention to the guys and the way that they're standing right now.
Crucial step in the formation of a.
All right, new guys, check this out. Now I've been disparaging in my remarks for the guys that turn on the death metal in the background and then they hunch over their anvils doing this number like it's a mosh pit. That's not how it works as a real blacksmith. These guys are standing straight up. You don't hunch over your work. You can if you're trying to show off and you want to look cool. These guys are sitting in there day after day doing this work. And so they stand in the manner that is least taxing on their bodies. Watch both of them.
A fine blade. A piece of high carbon steel is lightly attached cold and placed in the blast furnace. After intense firing, it is withdrawn, hammered at the anvil, and finally integrated as a blade with the pole of the axe.
Now, if you did not catch that, that is a two-position hammer. So the first position is right here. That's actually drawing out. But this one, that die head has been ground and set to mate with another piece so that it is at the proper height. So this is actually a two-position hammerhead.
For this demanding and
The other thing I'd like to point out is that beam of rock maple is about a foot from his face doing that. Now that beam probably weighs probably 400 or 500 pounds easily, and it's moving that fast, that close to his face. Yeah, look how close ever that is. But again, even as he's working the power hammer, he's not exceptionally hunched. He's leaned in. He's got him some space so he can scoot, but he's not in an unnatural position.
Dangerous work. Manson makes only $1.25 an hour, and soon he'll be heading down to Connecticut to work in a large mill, where he can make twice that, pushing a broom.
I don't smoke, but I would smoke just to do that.
Not only does the bit steel become a blade, but the axe begins to assume the final shape of the pattern design.
Once again, look, every time that you see tongs in this video, it's a different pair of tongs that is sized for a different piece of the steel in a different way, okay? And now, the other thing I want you to pay attention, look at the edges of this anvil. Every time somebody buys an anvil, if they're not pristine, they say to themselves, oh, I've got to have this redone or it's not good. Look at what the working person's anvil does. Now, the other thing I want to kind of point out real quick here is going to be the fact that, we talk about tooling. We're making one axe. Did you notice that there are literally 3 different helve hammers, 3 different hammerheads, most likely each of them having at least 2 positions to make this single axe? When I talk about making things in mass and making all these specialized tools, this is the graduation point of industrial manufacturing. Literally, each time there's an operation, there is a separate tool for it.
Whether it be a half wedge, Maine, Connecticut, Michigan, or Jersey pattern. The roughly formed axe now receives the refinements of final hammering. Hammering the head with a steel pin inserted through the eye ensures a uniform socket for the
Looks like he's wearing his safety squints.
Smooth and slightly tapering sides are permanently set under the trip hammer and at the anvil. The head is at last squared off by
now this next part will make your butt clench a little bit.
And finally,
so I got to point this out. And guys, I have really got to point out on this particular hammer right here, what you're looking like is that here is, we think about, one of these cast iron trip hammers, we think of that as being, kind of the top of the pile on that end of it. Here is another, that's probably maybe a 50 pound hammer sitting there. And it has been so specialized, it's been set a different type of anvil that has been wedged in. And look at all the damn wedges and the spacers that are locking this thing in. This is clearly fabricated. You can see some weld bead right here. That's got to be a piece of high carbon or something like that, right? So, but again, this thing is so freaking specialized that you have an entire power hammer that has a different type of bottom. And if you look down here, there is no anvil cone. I don't see an anvil cone like you have on these machines because they're usually cast into one piece. So either this one was broken or they simply repurposed it, which may be the reason, and they put a new envelope on there specifically just to square the back end of an axe head. Again, think about all the tooling that you've seen that's unique, handmade, that was forged for each stage of this work.
And finally, with a few light blows at the anvil, Manson has completed forging an axe.
Now this is super cool right here.
Forged axe is now
Now, a couple things here. And again, you really have to pause a lot of these videos to get the most out of it so that you can really see what's going on here. So one, I want you to notice all the electrical wiring that again looks like it was in my shop. Many of these buildings were retrofit from the 1800s. So all this stuff was added on top of the original building. It wasn't built with it. But if you look right here, so this right here is run off an electric motor. You can see the motors right here, but most likely there was a line shaft in here at one point that ran this grinding wheel. The other thing that you would not notice is this big ass thing right here. This is actually a blower. Most likely a dust collection system that's in there to keep all the grindings away. But that is a big centrifugal blower. They use those on a lot of the furnaces and forges at the ironmongers. These were what pushed a lot of the air into the molten metal. And clearly they've got a big one right here. But you can see that cast iron casing, and that's what that is. But it's actually been used to actually as dust collection. Look at the old nail keg in the back here. Now, this thing is super cool. What you're about to see here is this guy's grinding. But you're going to see an addition to what you normally are used to in grinding in the form of a spring-loaded pole in this guy's crotch. I know it sounds terrible, but this is a very common practice way back in the day to get extra pressure to grind heavier things. So check this out.
ready for grinding. This first grinding is called raising.
So you can see the post here, and I would hope that there is some padding going up the crack of his ass. But there is a large spring in there to have a little bit of give in there. And what's happening is there is a finger that's metal like this that he can actually push down on to give himself extra pressure against the stone of that wheel. Again, look at this guy. Now, most likely there are no bearings in this, not like the ones. Yeah, take note, there's no guard on his grinder. But the thing is, these most likely are actually bronze bushings. They're not technically bearings, or they may be Babbitt bearings, but they do not like modern ones. I mean, this has got to be late 1800s technology. And again, that is another great question, another great thing. Look at the posture, straight up and down and not hunched.
And here wood further shapes the axe by grinding off the top of the head and the side, and then grinding the bit down to the proper edge for tempering.
Now, two things. It's kind of hard to see.
Raising. And here,
but if you look, that is the metal touch piece right there, okay? That guy right there, that's putting pressure down on that blade. Now, if you've ever ground a knife, you know if you're pushing into that piece, you're going to burn your fingers. That keeps you from, you're able to grind the crap out of it. It can get hot, and you can do a very accurate job. But now, when he comes back to actually grind in the shape, the face of that blade, I want you to look at how he uses that same piece again.
wood further shapes the axe by grinding off the top of the head and the side, and then grinding the bit down to...
So now, this piece that a moment ago was used to actually press the blade into there is now acting as a table. So now, instead of it pushing down, he has the blade sitting on top, and he's using that to actually be able to radius the edge of that axe.
To the proper edge for tempering. The tongue he sits on gives him greater pressure between axe and stone, and a lot more steadiness.
Now, I just saw this. Go back frame by frame here.
Axe and stone.
I missed it. Hang on. Okay, look right here. Not only is it the one piece pushing, there is a secondary stay right here. So when he's using that as a table, it's giving him a very consistent angle. It's giving him a perfect angle to go into probably at 90 degrees to the stone. I didn't see that last part. So it's not just the little poker there. It's this top piece that allows him to set it onto a table.
The tongue he sits on gives him greater pressure between axe and stone and a lot more steadiness, all of which help him grind each axe to near duplication.
Bet that man has buns of steel.
And have replaced the traditional sandstone wheel. An average sandstone wheel used to measure 78 inches in diameter and weigh nearly 1.5 tons. Roy Barrett tempers the axes. Each axe, after reheating, is thrust into the ancient, bubbling tank of cold brine, where the sudden temperature change locks into the steel bit the hardness so essential to a fine axe. Barrett's skill at timing and eye for the look of a perfect temper are the key to this critical step. For if any portion of the bit is left soft, the edge will turn in use. If too hard, it is likely to break. These axes, the products of craftsmanship in forging, grinding, and tempering, now await only the refinement.
Again, notice the posture. And here's the other thing. The top of that wheel, the working surface of that wheel, the anvil, and everything these guys are doing is at the bottom of their shirt line, which I will tell you that if you stand up, put your hands to your side, and make a fist, it's the height of their knuckle or very, very close to it. All of these tools are set to the height of these guys.
The final grinding, paint and label, and the application of a handle before they are ready for purchase. Wood removes all rough edges, the marks of earlier raising, puts the final edge on the bit, and polishes up the bit about 3 inches. The skill of his hand has been an important part of the creation of these axes, from the raw steel bar to the glittering finished blade. When a blade bites into timber, the strength of...
So he's putting it on there and it needs to be level. Look at the block that he has actually made to keep the handle at the height he wants when he drives it. Also, there is what is essentially acts as the bottom die of a punch. It's got a shape in here to basically catch the head of the axe, but to allow the wood to pass through so it can be cinched up. Again, so specific a tooling.
The lumberman's shoulder becomes the force of the axe through the handle, and thus every good axe must have a handle of great strength and a head that fits true. This is Barrett's responsibility. His skill at handling an axe and his eye for alignment of blade and handle are unerring, and to a great degree, unappreciated. So too are most of the other steps and methods of axe making used in this shop. Not once in the creation of these axes has a precision measuring device been used. The craftsman's eye and muscle has determined the size, shape, and the quality of a fine tool, a product of the hands of men.
So guys, one of the reasons that videos like this are so important is because, you know, if you teach a class, if I bring somebody down here to teach a class, you can see me working. But the problem is, it's one of those situations where you're going to end up, you're never going to get to see the shop work environment when people are actually making something and a lot of it. Now, here's the deal. That's a real blacksmith shop, a real blacksmith shop. How many different items did you see being made? A professional shop with multiple employees making one thing. Guys, this is how the business works. You didn't, the more, usually the less, the more different things you make, the less profitable you are. These places specialize in these individual items. Custom work will make you go broke. So these people super specialized into making this one particular item. And you can see just, can you imagine? You can clearly go through each stage and look at all the different tools that are in place to make them. So, a fun exercise is to go back through and say, okay, if you were going to recreate this shop to do nothing but purely make axes, what all would you need? Well, you got to start with 3 tilt hammers or 3 different power hammers. Actually, make that 4 different power hammers. We saw 3 completely different grinding stages, the axe making stage, and understand that every time the camera changed angle, it was a different workstation manned by a guy, okay? So go back in and count how many specific dedicated workstations there were. When I talk about being in the shop that we have a dedicated area for leather, we have a dedicated area for wood, and the biggest aggravation that I encounter is when I have to swap that out. This is why. Because you want to be able to go over, do one job, and do it as best as it can possibly done, as quick as it can be done. Yeah, absolutely. All right, so guys, that's the review of the Pioneer Axe. I geek out when I get to do these things because I recognize so much of this stuff from the work that I've done. I recognize the work from, again, there's just a commonality there, and I'm so glad that I've kind of got into this because I can tell you about how it works in my shop all the time. But even my shop is nothing like this. At the height of the blacksmith's ability, that this is what shops look like, and they are absolutely super specific. All right. So guys, I think that's going to wrap it up. Again, I wasn't going to make this a super long video, like I said, so I want to get to the meat. But this gives me a chance to pause the video and let everybody really kind of soak in what's going on, why it's going on, and where it comes from. So I'm certain this is not going to be the last video like this that I do. I think this is going to be, yeah, I saw that. I was amazed they put the high carbon steel outside the softer steel to make the edge. So that's a real point I want to make about this. So here are axes. And again, all of us have seen you put the bit on the inside. Every Viking fan, you put the bit on the inside. Well, guess what? That's not necessarily how all the blacksmiths did it. And clearly, they did a fine damn job. So when you have the chance to go back and look at this stuff, there is so much to be gleaned from it. So I will put the link to the original video in the description of this once it goes up. But you should be able to look up again. The channel is Peter Vogt, VOGT. Again, they put some stuff up 7 years ago and have done nothing else. But anyway, guys, I hope you enjoyed that. I enjoyed the crap out of that. I know I'm going to do some more of these. Like I said, I think it was worth the time to go through, and I'll find some more goodies, and we'll do some more of these very soon. But again, thank you guys so much for being here. As usual, if you want to help support the stream and what we do here, there's a link in the description to make a direct donation to help the guys, the guy out on that end of it. Of course, you can go to the website, TrentonTide.com, buy my basic blacksmithing book, a hammer, and some other goodies. Or if you really wanted to be super, come to Patreon and support me every month. Even if it's $1, it helps, and we're glad to have you on board. Exclusive content, yada, yada, yada. Guys, thank you so much for being here, and I will catch you fellas a little bit later. Bon voyage!